Okay, everybody. So, today we're going to be talking about the last section from this chapter. So, the last section that's mostly about setting up and gathering data and experiments. So, this is one that's another one where there's a lot of vocabulary, not a whole lot of problems I can do as examples. Your book, again, to reiterate, your book has a lot more details. It goes into more depth. This here that we're doing is just a quick summary as a sort of supplement to sort of pull out some specific terms that are handy and to sort of connect with what we've done before. Yeah. So another thing about this section is that if this is a prerequisite for something in your major, if you have to take research methods as a psych major or pretty much any science class where you're doing experiments and gathering data, they'll probably go into this sort of thing in way more depth. We're just doing a sort of skimming over to get those ideas down, to have some language in our mind, but in general, with the problems we're doing, you're going to be using data that someone gives you and trying to analyze it, right? That's the mathematical part of this process, is taking the data and analyzing it. So for our purposes, this is mostly just a to be cognizant of, not necessarily a something that's going to have a big impact on what we do for the rest of the semester. But with that in mind, 1.3 is all about the process of a statistical. There we go. Sorry, I forgot how to spell for a second. Study. Right? And so as the book lays it out, there's a sort of 4-step process where one of the steps has 3 sub-steps. So it's kind of like a 6-step process. But anyhow, the first and the big step is to design your study. Right? And so the sub-steps there, first, what is the question you're asking, right? So when you are setting up a study, generally, like we talked about before, you do a statistical study because you want to answer a question. Whoops, not design, state the question. So you do a statistical study because you want to answer a question about a population. And that's a question and a population that, for whatever reason, you can't just ask everyone in that population. So to do a statistical study, you need to have a question that you want answered, right? And so with that question you want answered, you presumably want to ask a specific set of people. So the population, you want to find out something about them. And you want to know what the variables are, right? So that can be simple. If you want to know what Guilford College's favorite color is, then the population is people at Guilford College, and the variable is their favorite color, right? If you want to know what causes, man, this is one I didn't actually have something written down, but if you want to know what causes something in a particular neighborhood to happen, then your population are going to be people who live in that neighborhood, and the variables are going to be things like how many people are in their household, perhaps the income of the people living there, or the race of the people living there, or the genders of the people living there. So you can have one variable, like in the first one, favorite color. You can have multiple variables if you have a more complicated situation. But you always need to know what the variables that you're considering are. And lastly here is that you want to determine your type of study. And we'll get into that later, because that's one of the types of studies are one of the many vocabulary words that we have going for us here. So the second of the big steps is collect data. Right, and how you do that will depend on step 1C here. Then you want to organize the data, right, which is different, but often depends on what the variables are, right? If you only have to deal with the one thing, what's everyone's favorite color, that's going to be a lot easier to organize than data where you might be considering a multitude of variables. So once you organize it and figure out a whole bunch of things, this is stuff we're going to do for the next couple chapters. I know at least chapter 2 and beyond are going to talk about some ways to organize data. And then we move on to step 4, which is analyze that data. All right, so this is what I was going to get into, is when we're collecting data here, this is usually from a sample, right? Otherwise, it's not really a statistical study, remember, because statistics, or a statistic, is something that you get from a sample, right? So our question is about parameters, generally, that come from the population and variables. And then when we collect data, we do it from a sample, we get some statistics out of it, and then we organize those statistics and then analyze those statistics and see what they can tell us about the parameters. So that's the basic idea of this designing a study, of setting up a statistical study. And a lot of the sort of heavy lifting in this chapter comes from these two pieces, right? What do we mean by types of study, and what are we collecting our data from? So on the biggest level, the two types of studies that the book puts out there for us are observational and experimental. Right? So observational is, in a very, very general sense, looking at data that already exists and it's often best to answer the question, are things, right, where things here could be any number of substitutions related. Right, that's not the only type of question they answer, but that's often the sorts of things, and that's often the extent of what they can answer. Right? Experimental, those types of studies generate new data, right? And they can go beyond related to cause and effect. Right? So you can do an observational study and talk to people who, say, have been using a particular medicine and ask them the question of, did they get better when they took that medicine? And that could answer the bigger question of, does this medicine help people get better? Right? Or is taking this medicine related to getting better in any way? Whereas if you do an experiment, if you do an experimental study, then you're going to be doing things like giving some people the medicine and some people a placebo, and that lets you actually answer the question, does this medicine cause people to get better? Right? If you're just doing observational, then you don't know whether those people were also exercising and that made them get better, or if they were taking another drug along with it and that's the thing that made them get better, or maybe they got better all on their own, right? But an experiment is not going to be asking what happened in the past. It's going to be setting up a specific set of circumstances so that we know this taking the drug is the thing that caused the effect of getting better, right? And of course, a lot of times you'll go to observational if experimental is not ethical. A lot of times you'll go to observational because you want to know something about a historical thing, right? We can't recreate the 70s to answer a question about whether two things that happened in the 70s were related, right? We can't run an experiment on that. So they both definitely have strong places, and what you do is generally going to depend on the situation you're in, right? It's not a case of this type of study is better than the other type of study. They're just used in different places. So let's see. This observational data generally means when you're in this situation, right? When you're in an experiment, it's a little bit different because you are setting things up. The sample works a little differently, and that's going to depend on the experiment you're doing. But observational types of studies generally want let me get the right word, representative samples. And so there's a big question of how do we get that? So some of the methods that we have are random sampling. Right, so that's, say, if you have 5 people, right, you might randomly choose 2 of them, and it happens to be those 2, right? So I can't really give any proof that I chose those at random, right? But that's the idea, is you can choose any one of those equal chance of being selected. So each individual has an equal chance of being selected. So another option is simple random sampling. Which works a little differently in that each possible sample has an equal chance. Right, so say I wanted to choose 4 people from those 5, right? Then I could choose, that's one sample. That's another sample. That's a third sample. That's a fourth sample. And that's a fifth sample. So if I were to get a random number between 1 and 5, all right, so let's, then, I don't know, get run real quick. Okay, I got 5, so that's the sample that I choose, right? Each one of them were equally likely to be chosen, and my random number generator chose the fifth one. So that can be a little bit trickier because you have to come up with every single possible sample, and that can get to be pretty big, but it's one that a computer can do fairly easily. You can do stratified sampling. And that's where you divide the population into strata. Then pick randomly from each. Right, so maybe we've got 1, 2, 3, 4, 2, 1, 2, 2, 2, 3, 2, 4, 3, 1, 3, 2, 3, 3, 3, 4. And each one of these is a strata. Right, so I'm being a little bit loose with what strata means here, but generally it means that it's a group that shares the same qualities as the overall thing does, right? So in this whole big group, if we consider all 12 of these numbers, then a third of them have 1, a quarter of them have 1 as the ones digit, a quarter of them has 2 as the ones digit, a quarter of them have 3 as the ones digit, and a quarter of them have 4 as the ones digit. So we split them up into strata that have the same sort of basic idea, and then we choose randomly from each of them, right? And maybe we get that as our sample. So the next one is cluster sampling. And this is one where you divide, so you divide the population into clusters. And pick a few clusters at random. So in this context, clusters means the exact same thing as strata. So maybe we'll set up something similar. Right, and so here this is a cluster. This is a cluster, this is a cluster, and this is a cluster. And so for my random sample, I will choose the first cluster and the fourth cluster. So those 8 are going to be my sample, now that I've chosen randomly from them. There's a couple more, and I'm going to sort of split these off, because these 4 that we've talked about right here are random, right? And so they're the ones that have the best likelihood of being representative, right? It didn't actually talk a lot about what representative means, because it doesn't have a special math meaning here. That's what it means in English, right? Something that represents the population, right? So another way to do it that's less random and thus has some higher likelihood to not be representative. So this just means choosing every nth individual. Right, so in this case, you have to have some way to line them up in order. right? So maybe we have, right, and I want to choose every second, right? So that one is pretty easy to do, right? Maybe it's reading off a roll and picking every third person or things like that. When you when your teacher would split you up into groups by having you say 1, 2, 3, 4 over and over again, and then you go into 4 groups, that was a version of systematic sampling. And then convenient sampling. Let me make sure I spell that right. That should be is where you just pick ones that are easy. So pick individuals at your convenience. One day I'll be able to write the word correctly. There we go. So whenever you're asked to take a survey after having gone to the mechanic, right? That's taking a convenience sample. Anytime you walk into a store and they ask you to try something and let them know if you like it, that's a convenience sample. Anything where you're just picking targets of convenience, you're asking whoever's easiest to get to. If we were to try to do a study of Guilford College by asking everyone in our class something, that would be a convenience sample, right? It's highly unlikely to be representative, but it's very easy to do. And so that's not always the biggest problem. The book gives a great example of if you are smart about how you do convenience, then it would work, right? If instead of saying we wanted to do a study of Guilford College, if we said we wanted to do a study of, let's see, I'm going out on a limb here. I haven't actually looked at the data, but if we were doing a study of first years at Guilford College, then this class would actually be a decent sample, despite it being a convenient sample, because there are a lot of first years here. I know not everyone is a first year, but if that was the specific part of the population that we were more concerned about, then it wouldn't be the worst one. So we have, let's see, a couple more different types of studies, and then I think I'll stop throwing words at you, at least for right now. So we have cross-sectional, there we go, and longitudinal. And I'm putting these next to each other because they're sort of opposites of one another, right? Cross-sectional is specifically looking at a single point in time, a snapshot, if you will. And longitudinal follows a particular group over time, right? So it looks at the long view, the longitudinal study does, of what a particular group is doing. And then we also have meta-analysis. Let me check on, there we go, that's how we do that. Meta-analysis is where we study some studies, Right, we take a look at all the studies that have been done about a particular thing and try to either take all their data and analyze it or analyze their conclusions, or things like that. It compiles information that's already been done, but in a bunch of different places, all into one place. And a case study is something that looks at the way multiple variables affect a single event. Right, so it's looking at a specific sort of case, right? One case of things, looking at it in depth, looking at all the possible values that might be associated with it. Instead of it, these are also sort of opposites. It's kind of why I put them across from one another. Is that a meta-analysis looks at sort of all these different events and gathers them together and looks at all the data that all these different studies have come up with, whereas case study is going very deeply into one event, one thing that happened, looking at all the different variables that might affect it. So I think that's all the different vocabulary that we have here. Well, it's all the vocabulary about studies, rather, not all the vocabulary that we have here. Let's see. There's a little bit about experiments that we have here. But those are, like, I don't really know anything more that I could add to the, like, one-line definition that the book has. Studies and samples tend to be a little bit more complicated for folks, so I wanted to sort of bring up both to be able to both compare and contrast, whereas for the rest of the definitions, the discussions on experiments, I would basically be writing down the block of text that is the definitions in the book. That doesn't sound like a good use of your or mine time, so I'm going to remind folks again that these are supplements to the book. There's not really anything I can supplement from this section for the experiment part, so I'm going to leave that to the book to go over, and I will see y'all next section.